Okay, I'd like to talk to you a little more about the force of gravity. So last time we talked about how gravity acted between all objects with mass. So we have the sun pulling on the earth pulling on the sun, the earth and the moon and the sun. All objects with mass pull on all other objects with mass. We learned how to calculate the force of gravity between a planet and a star. We learned that Newton was the one who came up with the relationships for force gravity. We had the formula for force gravity looking like this. Gravitational constant, 6.67 e to the negative 11. The mass of the two objects in kilograms, and distance from center to center on the bottom. We saw that this comes up in newtons, and these have to be given in kilograms. We saw the masses of the planets given to us on our reference sheet. We saw the distance they were from the sun, also on our reference sheet. We learned how to calculate gravity between a planet and its moon, or one of its moons. And I also want to make sure you know how to calculate gravity if you had to find it between two planets. So to get the distance between these two planets, you'd find out how far Venus is from the sun, how far is the Earth from the sun, and you'd subtract to get this distance. Okay, so today what we want to do new is we want to do the force of gravity when you're on the surface of a planet. Okay, so we have an object sitting on the Earth's surface and we want to know the force of gravity. So when you measure distance, you measure from the center of the planet. Do not measure how far it is from the surface. It's being attracted to all parts of the planet, so on average, we use the center of the planet. So when we do our formula, we use the gravitational constant. Mass 1 would be the mass of the planet, in this case Earth. Mass 2 is the mass of the object. In this case, it's my little polar gummy bear, which has a mass of 2.1 kilograms. And for radius, you want to use the radius of the planet and you square it. Okay? So you go back to your reference sheets. You'd use the mass of the Earth, and this time use the radius of the Earth. So don't put how far it is from the sun or moon, they're unimportant. Use the actual size of the planet. All right? So when you plug in our gravitational constant, mass 1, we could use the Earth, 5.9742 e to the 24th. Mass of the polar bear, and the radius of the Earth squared. All right? So you punch all that into your calculator and see what comes out. Okay? When you're on the planet's surface, you probably don't want to go through this whole process every time you're trying to find the force of gravity. So instead, on the planet's surface, we find what's called the gravitational field. We saw this when we did lab this week. We found that our slope was the gravitational field for that planet. So the way you find the gravitational field is you do the exact same formula, but for mass 2, instead of using an actual object, you imagine a 1 kilogram object, in this case a 1 kilogram cylinder. When you plug all your numbers in and get your answer, you'll get the force of gravity in newtons on a 1 kilogram object. So that answer will tell you the number of newtons you get per kilogram. We're going to abbreviate that with just a small g that stands for the gravitational field of that planet. So again, you use your force gravity equation once on the planet, using 1 kilogram as your mass, and you will get a force that represents the number of newtons per kilogram for that planet. Again, this only works if you are at sea level on that planet. Okay, so once you have the gravitational field for that planet, you could then take a shortcut, and instead of using that big long equation, you just utilize the gravitational field to get the force of gravity. So if we want the force of gravity on this apple, we plug in the gravitational field of the Earth, and we multiply by the mass of the apple in kilograms. Okay? And when you get your answer, you've got your force of gravity using the gravitational field, which is much easier than using that big long equation multiple times. Finally, what if you get an object's weight in pounds? Remember that weight is just a synonym for force gravity. So you have the weight, but it's in the wrong unit. So I want to make sure you know how to convert. And 1 pound is equal to 4.5 newtons. So if you have to convert, you take your pounds, you turn it to newtons. On the other hand, you could also take the pounds and you will see sometimes people will turn pounds into kilograms. And 1 kilogram is about 2.2 pounds. And then once you have it converted to kilograms, you would then plug it into your force gravity formula. You should get very, very similar answers. Realize that this is the better procedure because newtons and pounds are both units of force. When you do this conversion only works on Earth. This conversion would work anywhere. On Earth, 1 kilogram has a force gravity of 2.2 pounds. That will not be true on other planets. All right? So hopefully you guys understand how we can use force gravity on a planet's surface. I hope you understand that it's easier to find the gravitational field. When you use your gravitational field, make sure your masses are in kilograms. And if you get your weight in pounds, remember that pounds can be converted over into newtons. All right, that's it for today.